When we are describing a vector, we use coordinate axes to find the components of the vector. We use coordinate axes to create a mathematical description of our vector. But coordinate axes are a mathematical construct. They are something that we have created to help us describe the vector. The vector itself represents a physical quantity, a physical value. This could be a velocity, it could be a force, or what have you. But a vector has a magnitude, which is represented by the length of the arrow, and it has a direction, which is the direction the arrow is pointed in, the orientation of the arrow. And so this same vector, these two vectors here are the same vector because they have the same magnitude and they are pointing along parallel lines. I can use standard axes, which have my horizontal, which are the horizontal and vertical axes we're used to using, or I can use rotated axes, and neither of those changes the vector itself. But I can describe the same vector using components that align with my standard axes, or I can have different components, a component in the x prime direction and a component in the y prime direction that align with these rotated axes. We use rotated axes when we have an acceleration that's in a non-standard direction. We can align the axes with our acceleration. If our object is moving on a ramp or on an incline, it makes sense for us to use axes that are aligned with that incline as well. The key to using rotated axes, axes that are rotated by some angle phi relative to your standard axes, is that the vector itself can't change. The vector has to keep the same magnitude, and it has to point in the same direction, have the same orientation that it had before. What changes with the vector is that it has a new angle, theta prime, that is measured relative to the new axes, as opposed to its original angle, theta, which is measured relative to the original axes. So if you need to find the components of a vector from rotated axes, or if you have the components of a vector from rotated axes and you need to convert those back to standard axes, what you need to do is find the magnitude and the direction in either coordinate system. The magnitude is going to be the same for both. So once you have the magnitude, you know what that is. You find that from a right triangle here or from a right triangle there. Once you have the direction, either you'll know the direction in the rotated axes or the direction with the original axes. You know that the difference between those two angles is different by the amount by which the angle, the axes are rotated. So if this is theta, we see that this angle theta between our vector and the horizontal would be theta prime plus phi, is that same angle between our vector and the true horizontal. And so you can convert from one angle to the other based on what you're looking to find. Once you know the magnitude and the standard direction, then we know that our x and y components can be found using trigonometric relationships using those right triangles, which we have done many times before.